All right, I'm continuing on in the section about volume rotation. And the next problem says the following. A solid is obtained by rotating the shaded region about the specified line. So we are taking this region and rotating about the x-axis. This problem is specifically asking us to use the shell method, but this time, interestingly enough, we're using the shell method to try and rotate something about the x-axis. Now, I want to just make sure to reiterate that typically we would not do this. We would use the disk washer method when rotating about the x-axis. But just to show that it is possible, let's see if we can go ahead and set this up. So the first thing we are going to have to do is to rewrite our equations. I have y equals square root of x. I will need to give this as x equals y squared. And then y equals 12 minus x. I'm going to give this as x equal to 12 minus y. All right. So if we decide to, if we're going to rotate this thing, let me see if I can draw. I'll do my best to draw a decent representation here. If we rotate it this way, it probably will look something like this, right? And so if I were to draw a shell, sort of an arbitrary shell, I'm going to draw a shell right here. So if I take this region, or this little strip, and we rotate it, we will see that a shell forms. So we kind of see the shell forming. All right. So we're going to have to find a point radius. So the point radius is going to be this distance. The distance from, again, arbitrary, my shell is made, oops, not at x, but at an arbitrary height y. And then my axis of rotation here is the line y equal to 0. And so we're looking for the distance in between. So this distance in between is going to tell me what my point radius is. This is what we call the point radius. So for this problem, I'll put this over here. The point radius, in this case, top minus bottom, because it's always a distance, it's going to be y minus 0, so it is just equal to y. So I'm going to go ahead and set up this integral. So volume is equal to, this is going to be 2 pi times the integral of the point radius times, so this will be f of y minus g of y dy. We're going to be integrating with respect to y. All right, so for my problem, this will be 2 pi times the integral of the point radius, which we said was just equal to y. All right, so here, instead of top and bottom, these functions are going to be right minus left. So the right minus left, the function on the right is the 12 minus y, and the function on the left is the y squared. And then finally, we need to put some bounds on this integral. And so again, we're going to look at essentially we're going to look at the range for this region, right? So I'm looking for, so from here down. So this would be the range, this region right here. So we see that goes from 0 to 3. All right, another problem says that a solid is obtained by rotating the shaded region about the specified line. In this case, we are rotating about the line x equal to negative 2. All right, I can see that I should have labeled this. All right, this is the line x equal to negative 2, actually. All right, so not drawn to scale. I did not have enough room on this page to draw this to scale, but this is the line x equal to 2. So if we take this region on the right and we rotate it, it is going to look something like, it's going to kind of end up somewhere over here. So like this little region over here, right? try and see if I can draw this in a way that's going to make it look like it has been rotated. Let's quickly draw axis of rotation here. So there's that, and then all right, so that's more or less what that region is going to look like. All right, so let's go ahead and set up this integral. Again, we're going to use the shell method because we are rotating about an axis that is parallel to the x-axis. So I'm using the shell method. So that means that we need to find a point radius. And again, the point radius, if we were to pick an arbitrary shell somewhere in this region, this arbitrary shell is going to be at a point x. We're rotating about the line -2. The distance between these two, this distance between them, this is the point radius, right? And so in this case, the point radius is right minus left, so x minus -2, so this is equal to x plus 2. So let's set up that integral. Volume is equal to 2 pi times the integral of the point radius times f of x minus g of x dx. And again here, just to be clear, this is top minus bottom. All right. So this is 2 pi times the integral of x plus 2 times the function on top. That is the function y equals 3x squared minus the function on the bottom, y equals 3x cubed dx. All right, finally, my bounds. And again, to find those bounds, always refer back to the original region when you're looking for the bounds. It is going to be this domain. Since we're integrating with respect to x, it is this domain that region is defined on. So in this case, from 0 to 1/2. And there it is. This is your integral.